Alright, in this video I want to talk about factoring and quadratic equations. Alright, so let's get into it. So factoring will start simple and slowly get more complex. So if I had 4x plus 2, factoring means you turn into a product. So you need to see what each of the terms are the pieces, the blobs of an expression that are added or subtracted from each other. In this case, 4x and 2. And people talk about pulling out a common factor. So you can divide each term by 2 to see what's left, and that's how you can figure out that is the factorization. All right, and let's do another example. You can have lots of letters and lots of other drama going on. Okay, factoring something like this. They have a 3 in common, but they also have an x and a y in common. So the leftover, and the a just comes along for the ride. 3xy plus 30x squared ya. Okay, so that's another example of factoring. And another example that comes up is something like the following. What if I had, let's see, a squared plus a plus 2a plus 2. Now, this is going to be called factoring by grouping. If you look at these terms, they don't all have a common factor. There's not something you can divide all of them evenly by. Okay, that much is certain. However, you can group them and divide pairs separately, or factor pairs separately, and it turns out sometimes that you get lucky and that works. So let me show you what I mean by that. So the first pair does have something in common, and the second pair also has something in common, and lo and behold, the final product also has something in common. In this case, the a plus 1. Okay, so look at that. That's another type of factoring you'll see sometimes. Okay, and then the other kind of factoring you'll need to be responsible for is quadratic equations. All right, so something like this. Okay, and you need to be able to see that is x plus 4x minus 1, and you can check that by, if you remember FOIL, you can expand it out to see if indeed that gives the correct original expression again. All right, and another common another type of factoring is where the coefficient, that's what's the number in front of the variable stuff, is called a coefficient. If the coefficient in front is something that's not 1, like a 2, you should be able to factor something like that. Okay, now they may or may not factor. I could put a bunch of these, and maybe some of them factor, maybe some of them don't. Okay, even if they do factor, it's not obvious how they factor. Okay, what you need to do is you need to be able to make the two parentheses and know how to split up the pieces. Okay, all right, and so this, what I just wrote there, that would be the factorization of 2x squared plus x minus 1. Okay, you can FOIL out what I just did, and then you'll see that indeed that works. So that's something you should be able to do. Hopefully that you have good memories of doing that in your previous math classes. Now, what about if you can't factor the dumb thing? Okay, I just gave you a bunch of similar quadratic expressions, and I said some of them may or may not be able to be factored. All right, well, that would be a bummer. Well, what you can do there is something called completing the square. So let me go to a new page and I'll talk about that. So x squared plus 2x, let's say minus 5. And let's say that was equal to 0. And we really wanted to solve this equation. We really wanted to factor this. Well, 5 minus 5 is only going to split up into something like 1 times minus 5 or minus 1 times 5. So you're not going to be able to factor this. We're out of luck. All right. However, what if I tweaked this equation by adding 6 to both sides? Okay, now I'm able to factor the left side. Not only do I factor it, but both pieces, both parenthesis blobs are the same, which is kind of nice, kind of slick. And so then you get a nice clean factored equation, and you can even solve it. Okay, and so x is minus 1 plus or minus root 6. Okay, so this is called completing the square. Now, how did I know that adding 6 was going to make everything wonderful? The trick is to, if whatever the coefficient of the middle term is, you chop that in half. So if I chop this in half, that would be 1. 2 over 2 is 1. Then you square that, and that gives a, well, it gives a 1, right? So you need to add whatever to both sides will turn that minus 5 into a 1. So that's how I knew it had to be a 6. Okay? And so you should be able to practice, you should do a couple of practice problems using this idea. And here, let me make another comment. What if you had an annoying coefficient next to the x squared? So what if I had like 5x squared plus 10x minus 7 equals 0? All right. What I would suggest is you simply divide out that coefficient. You're allowed to do that. So divide everything by 5. All right. Yes, you might have a fraction, but at least you don't have that coefficient on the x squared to deal with. All right. And then you could just proceed exactly how you did before. Okay. If you studied the general pattern, you'd see that all quadratic equations, you would complete the square pretty much the same way. All right. If you took a generic quadratic like this, okay, and you imagine dividing both sides by a, because I said that that's how you get rid of that coefficient in front, okay, and then you know that you need to convert the c over a to something. What do you need to convert it to? You need to convert it to the square of half of the middle guy, so b over 2a squared. Okay, you could keep going down this procedure, doing the completing the square recipe, and you would notice that you would get a certain pattern, a certain form, and so that would be the pattern that would work for all quadratic equations of this type, which are all of them. Okay, so let me just, you can finish that yourself if you're curious. It's not that hard to do. But if you did, you would get the following pattern. X is negative b plus or minus the square root of b squared minus 4ac all over 2a. Couple of comments. Notice there's two answers in there, the plus and the minus. Okay, notice that you have a square root of something that may or may not be 0 or positive. If the argument of the square root is negative, you have complex solutions. If the argument of the square root is 0, you've got one solution. Okay, and if the argument is positive, you have two solutions.